Take a look at this piece of art. I was actually able to create it without touching brush to paper. How do you think I did that? Was it magic? Was it through the power of my mind? Believe it or not, science has the answer. I was able to create this through the power of magnetic force. So what does that look like? All I did was I took some screws, dipped them in some paint, and then took a magnet and I run that on the bottom of the box. By creating this art, we are able to model how fields exist between objects, exerting forces on each other, even though they're not in direct contact. How cool is that? The closer I get the magnet to the screws, the more I can move them around. It's this invisible magnetic field that is moving things around without physically touching them. All magnets have north and south poles. Opposite poles attract, while like poles will repel each other away. Let's take this a step further, looking at some iron filings. So I just have some iron filings here. Let me put a piece of white paper underneath that so you can see it. And let's see if we can see the magnetic field that forms around this magnet. Move that around a bit. Where do you think the magnetic field is the strongest? If you said around the poles, you're correct. All right, so now that we've discussed magnetic field, why don't we try and create a coding program that will actually tell us whether the polarity of a magnet is north or south. All right, so I'm going to go ahead and pull that program up for you first and show you what it looks like. And there's a lot going on here, so don't worry, I'm going to explain it in a second. But first, let's talk about the data that you might need to do this program. Well, we've talked about magnetic field strength, and the code.Node actually has a magnetic field sensor inside of it. So let's take a look at the SparkView screen, and I have my magnet here. I'm just going to start this, and I'm going to bring the magnet up to the code.Node. This is actually the south pole, and I want you to notice the closer I get, the stronger the magnetic field. Flip it around and show you the north pole. The closer I get to it, the stronger the magnetic field. So again, it's interesting to note that the north pole is seen as a positive field, while the south pole is seen as a negative field. And it's actually measured in Gauss, which is the unit of measure for magnetic field strength. All right, so now that we have that, let me show you the program. I'm just going to explain it quickly, show it to you working, and then we're going to build it step by step together because there are some key pieces here that you might need help with. All right, so initially I'm telling the program that I want the code.Node to be off, so no lights will be turned on when the program first starts. This particular program, we're going to be creating 3 variables, north and south for the poles, and then heading for our measurements. I'm going to explain how to do this shortly. All of these numbers here actually represent the 5x5 LED array in the code.Node. We're telling the program to run continually until I push button number 1 or I hit stop. Then we're setting the heading, which is the mathematical piece we're going to need in this program to read as the magnetic field strength. We're going to be using absolute value, and just as a reminder, an absolute value is always going to be a positive number. And we're going to state if the heading is greater than 1 Gauss, because remember positive was the north pole, it's going to illuminate N on the 5x5 LED array. If the measurement is less than -1, that's going to indicate a south pole measurement. And then this final one here just clears everything out so it doesn't continually say one or the other. All right, this is a pretty big program, so let's build it block by block together. Don't worry if you can't keep up because you're going to be able to refer to this video to help you out, and you can also refer to your book as your resource. So the focus that I'm going to be looking at in my book is going to be magnetic polarity, and that's where I'll find the program. All right, let's start from scratch. I'm going to click the code, go to the hamburger, and start a new experiment. All right, first I'm going to click on sensor data, and this is where you're going to see all the sensors on the code node that you can enable or disable. For this activity, the only thing I'm going to need is magnetic field strength. So I'm going to disable the others, except for let's leave the button. Because remember, we said we could turn our program off if we clicked on button 1. So we'll save that guy. Okay. Then I'm going to click the code icon to bring me to my screen. All right, let's get started. Remember I said that there are going to be 3 variables that we have to create here. So to do that, I'm going to click on variables, create, N for north, create again, S for south, and then heading. All right, so we want to start with the light on the 5x5 LED arrays actually being blank. We don't want anything showing up. So I pulled out from hardware, I was able to pull out this block that will tell us what to do with that array. I'm going to take out the numbers that are set in there and set the brightness to 0, which means lights will be off. Then it's time for me to pull in my north and south poles. It says heading here, but you just have to click on that down arrow to select the ones that you need. I need to set what I want my LED arrays to illuminate. So before I go into coding much longer, I want to direct your attention to this array, because this is going to be something different for you guys. In math, you've probably plotted coordinates. The plotting for the array on the screen, it's computer science language. So the top of this array is actually 0, 0. And then the bottom is going to be 4, 4. And this is important because if I say I just want to illuminate the top row, I'm going to choose 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, and so on. What I did as an example for you is showed you here what you're going to have to choose to show an N for North Pole and an S for South Pole. All right, so I'm going to leave that there, but now I'm going to do the tough part and plug that into my program. So the coordinates I need for this are going to be 04, 03, 02, and so on. Again, don't worry if you miss something here. Okay, so that's going to illuminate N. Now let's do south. You'll notice that I don't have commas in there. That's okay. If you want to add them, you can. It won't hurt the program. I just think it's easier not to put them in. Almost there. And last one. All right, so now these variables, when they're recalled, will illuminate only these LEDs within the 5x5 LED array. All right, then I'm going to pull in a loop. This is going to tell the computer to continually run through this program until I do something to stop it. So until, and we said we'd have a little fun with this one, so we'll say we can stop the program when the value of button 1 is equal to 0. All that means is I'm pressing button 1. Okay, now I'm going to recall and set my heading to the value of the magnetic field strength. I'm going to bring in a logic block, and I'm going to have it state that the absolute heading, and let me show you where you find the absolute block, because it's not super easy to find right off the bat. I clicked on the math blocks, and where you see square root here, the third one down, I'm going to plug that in here, and I can change that by the drop down arrow. So there's absolute value. All right, so when the absolute value of the heading, which remember, the heading could be negative or positive depending on what pole we're focusing on. So this is saying that it's going to be a positive heading regardless. So as long as it's greater than 1, it's going to do the following. I need to pull in 2 more logics within this one. You can pull from here or you can duplicate. I like to duplicate it because it's a little bit quicker. And for here, if the value of the heading don't let that deter you. They like to run away from you sometimes. All right. If the value of the heading is greater than 1, this is a positive number, I am going to have the lights. This is where I can recall that variable. There we go. Set brightness to 5. So if the value of the heading is greater than 1, it's going to illuminate and show an N. I'm going to duplicate this block just to make things go quicker. But if the value of the heading is less than -1, then I want it to illuminate with an S for south. And then to make sure it doesn't stick with one of these, you have to clear all, then set. If you hadn't done that, you're going to see N and S all together on the screen, and that's kind of a mess. And I got one more block. If else. So if the absolute heading is greater than 1, it's going to, absolute value greater than 1, it's going to do one of these 2 things. If not, I want it to have the light off. All right, so there's a lot going on there. I'm going to do a quick check of my program. Everything looks where it's supposed to be. All right, so let's draw our focus now to the code node and my magnet. So I have my bar magnet and I have my code node. And if I have done my program correctly, when I hold the south pole up to the magnetic field sensor here, it's going to say S on the screen or N. Let's give it a whirl. I start. Excellent. It appears that we have done it correctly. I know that this was a pretty extensive program. There were a lot of pieces to it. Important things to remember are how you program the LED array if you want to do that in the list format, and also how to create the variables so you can recall that information later in your program. Good luck. I hope you have a lot of fun. This has been Magnetism.